Hello everyone, I'm Philippe Kanonikov, aka Wondertan, and I'm from Celestia, and I wanted to present on this interesting topic. But before, I want to do like a little, a little prelude. So, like, I actually give free talks over this week, and I wanted to make this one not related to my work. I wanted to make something fun for the p2p community, and originally the idea was to build a new transport for p2p, which is based on LoRa radio. And I started working on that. However, it's like a rabbit hole, and it didn't prepare any POC. So I'm kind of person that I need to POC to present you. I won't just like talk about like the high level idea. But it's like the idea is pretty cool. You can have like a multi-address with the frequency there. You can make two Raspberry Pis talk to each other over P2P, which is very, very cool. Maybe eventually I will get to the bottom of it. But instead, I will talk to you about data availability. Yep, and how it's related to P2P. Okay, so, oh, nope. What is data availability and or publication? It's like another name. And first of all, I want to ask a question. Who heard of it here? Like, what's data availability? Okay, we have some hands. That's cool. I think that the best way to answer like what is data availability is to explain why data availability. And I like challenge myself to find out a good enough analogy from the real world that will explain it, because it's really hard to grasp it from the first time. Like even for me, like I've been working for Celestia for 2.5 years, and like it clicked only like after some time what it actually is. So to explain, I'll give you like an exam analogy. So imagine there is a group of students who are writing an exam, and all of them submitted their results to some server in a university so the professor can like verify and like give them scores. And imagine that one of these students decided, like, was able to hack into the system, and he basically withheld or erased his results from the system. So like on the front end, you can see that, okay, he submitted the data, but in fact, the data is not there. So, and he also sort of like tells everyone, I submitted a test, it's there, everyone can like, he says like, okay, I did a great job there, everyone believes him, but like, in fact, there is no data for that. So like, you end up with a situation where there is some data that needs to be verified, but it's not there, and no one can access it, and it was withheld. And it's like sort of an attack vector. The next thing, like we need to talk about this more like abstract example. Who heard of rollups here? Cool, more hands. That's much better. So rollups has exactly the same problem. They have transactions sent on like some sort of a base layer, and that transaction can be withheld. So like some sort of a node on the network who wants to see that transaction, verify its correctness, may not be able to do that. So, and verify that it's correct or not. And for that, this data has to be like available in the first place, but it's not. And like, okay, it might be not, and this is what availability solves. So another thing I wanted to like cover here is why the availability versus proof of storage or any other storage solution. So storage, like let's imagine the Filecoin. I think most of you understand the mental model of Filecoin, where you have like a storage provider who has a storage deal, and it proves over time that, okay, submits proof that that data is stored for sure, that we have a proof. However, there is a problem, a censorship problem. That storage provider can still hide the data from some IPs. Imagine like that IP is like Russian, for example, or whatever, and I want to serve you that. I don't want to serve you the data. But the important property of data availability is that any honest actor can come to the network and get the data from somewhere. No one can censor it. So it's somewhere available in distributed manner, and anyone can go and fetch it. With proof of storage, it's not exactly the case. It doesn't give you these properties that you want. You can technically build something on top of proof of storage, but it will be insanely slow. So like onboarding data to Filecoin is slow, and to make a data availability there, you would need to like also make a lot of storage deals and stuff. So that doesn't scale. So I want to like also explain like more generalized model of thinking or framework, how to think about data availability. So imagine there's someone who makes a claim or statement, and someone can, like some other person needs to verify that claim, or say like it's false or true. One sec. Yes. So someone needs to make a claim, either it's and post it somewhere, and someone has to like attest to that claim. Is it correct or not? Like the other example would be like, okay, let's say some of you like write something on a paper and some statement, and I can see that statement personally, and I say like it's wrong, but then the person who wrote the statement on the paper burns it, so it's disappeared, and I say that what he said there was wrong, and I'm trying to prove you that it is wrong, but it's impossible to prove you that in the first place because that thing is non-existent anymore. So this is like a crux of data availability again, another way of thinking about it. Now I would like to, now I think I explained it somehow, what's DA is about, and I want to like take a look more deeper into like Celestia's DA schema, and also like how the p2p comes into the place. So for that we need to like enter the 2D square. So the 2D square is a core data structure of any data availability protocol. When you have all these transactions that are sent to the block, they're sent and packed as a form of original data. Then that original data gets extended 2 times, a 2-dimensional data square. On the right, and down, and you have like a erasure-coded block of data with the interesting property. You can have some sort of a node on the network that's that only needs to sample like dozens, like 10, 20, 30 samples in order to get guarantees about data being available with 99.999% guarantees. So that's an like interesting way. So just by sampling tiny bit of data, and because of erasure coding magic, you can be sure that the data is somewhere and it's there, so you can go and verify it. So this is like a little diagram that explains sort of a topology of the network. So there will be more slides, and this is a setup that required for it. So imagine there's like a full node which stores all these block data, and there's many light nodes that do sampling from that storage full node. And all of this is p2p network. They exchange various data types here, like actual shares are samples, headers, like proofs of something which something went wrong. It's called fraud proofs. But yeah, this is basically like the topology we have simplified. And this is like a more detailed diagram of the sampling. We can see here a full node 1, full node 2, and 4 light nodes. All of them on a p2p network. And in the core of it, we have a bit swap. So this is what we reuse from IPFS to sample. Because sampling is a content identified, content addressable sort of a protocol. You want to request some particular sample by its hash, and you also will verify that it's committed to the block. So light nodes decide randomly, okay, I want to sample like this red one samples from full node, these samples and this one, and then all the others do the same. So they do sample the whole block. And so now that block is just distributed around all these light nodes in a network. And now we're coming to like another core property of data availability. So in case someone still tries to attack the network and withhold the data, so you may want to like just hide it. So these malicious nodes can try to hide the data so that light nodes cannot access it and cannot verify. In that case, there is an assumption of another honest full node. So we have an assumption that at least one honest actor have to be in the network that will talk to these light nodes and fetch these samples they sampled to reconstruct the whole block back. So you can see here, again with colors, this is basically the previous picture with the full nodes, another full nodes attached. And this full node gets all these samples. It doesn't have to even get all these samples. It just gets some, at least 1/4 in order to reconstruct the block and make it again available for anyone to verify. I think this is basically it.
Hi, thank you for your talk. Is this data availability model similar to those that is used in proto-den sharding and den sharding?
So the proto-den sharding doesn't have any light nodes yet. So there is another proposal called full proto-den sharding that will include light nodes. But for now, it's mostly like just erasure coding without sampling. So they just increase the throughput of the network. They add more, basically, blob space to it through erasure coding and KZG commitments. But it's not as advanced as our current approach. But they will get there as well, for sure.
Hi. So 2 questions. Can you go back to the previous slide?
Yep.
How does this good node at the bottom know which light nodes to contact?
That's a great question. So the current approach to this problem is that light nodes, which we expect to be like sort of a browser nodes, and we're working a lot to make them browser compatible. We like few folks, our friends, implemented a Rust WASM for web transport, and now they're working also on a Golang WASM for web transport. But it's like a sidestep. How they work is that full nodes advertise themselves on a DHT, and light nodes find them. So there's currently an assumption that full node will have enough light node connection on the network to reconstruct it. So like every time light node goes on a network, it discovers some full nodes, it talks to them. We soon will also add rotation. So like full node, in the worst case, will just wait some time until it can reconstruct the data in case it's unavailable. So light node connects, and then another light nodes connect, another. It gets rotated. So like light nodes maintains a list of full nodes that advertise and rotates them. Makes sense, or not?
Yeah, I think. Yeah. The other one was.
And then like bitswap, we do bitswap requests for that, which is also very inefficient right now. Like it's just like full nodes. Bitswap is very like chatty, noisy. So this is not the best use case of bitswap, because also full nodes doesn't really like light nodes store only sub portion of it. So bitswap is very effective for when you light node sample from like full nodes, like when we go from here to here, because full nodes have everything. But when vice versa, full nodes just like spam all the light nodes with all the requests they need, and light nodes get basically a lot of unnecessary requests. But there's some ways we can optimize that. Yeah.
So the other one was, so if you look at all the light nodes in the network, are they combined keeping all the data with them?
Yes.
So what sort of is the ratio that you expect to happen between full nodes and light nodes?
That's also a good question. We don't have like a particular ratio. Like the, again, assumption is that network should work securely if there's at least one full node, which is honest. But eventually there will come to a problem like load balancing issues, right? We will need to ensure that like there's enough full nodes to serve the load of this amount of light nodes.
Sure.
So, and right now we just based on, it only works on like basically DHT discovery and how like randomly which full nodes you connect to. But it's like open research question for us right now, because we can either keep using DHT, or we can do more like deterministic load balancing. And like there was an idea we had, like implement a new gossip subrouter, which knows, like, aware of node type, so it will make sure that full nodes has like a mesh degree of like hundreds of light nodes, for example, rather than like only be connected to a few of them. So there were various ideas and towards this direction, which are not yet settled.
Oh, nice. No, yeah, thank you.
So I understand that the bit swap, you want the bit swap session to have as high throughput as possible. Is that correct? In order to make it as efficient as possible.
Bit swap what?
You need bit swap to be as efficient as possible in order to have high throughput between all the light nodes and the full node.
Exactly, yes.
Right? And do you have a different session for like full node 1 to light node 1, full node 1 to light node 2? Or is it
bit swap sessions, you mean?
Yeah.
So like the way we do it right now, like this is one block, right? It's block 314.
Yeah.
And these blocks are produced every like 10 to 12 seconds. And usually like light nodes maintains the same session for all the blocks, just because we assume that all the full nodes have the same data, right? And the same session showed us that it's actually better in terms of like time to fetch the samples.
Right. And one quick other question. Maybe you mentioned I didn't get it. So I guess you're representing every one of these blocks with a CID.
So this is another good question, and we are currently like transitioning from protocol of old version and newer version. So that there's another additional detail about the block, which is for every row and column we build a Merkle tree. Okay. And currently the protocol is inefficient in a way that not just you like request for a particular sample, but you also traverse a binary Merkle tree from the root to the leaves with a bit swap. So you do a lot of round trips back and forth. Okay. But like there is already a finished implementation of the new protocol that's actually hacks a little bit of multi-hash, because multi-hashes only allow you to do just like a hash, but we include in the hash some additional information like block height or index, and we integrate some custom multi-hashes in order to like make BitSwap work with that. It's kind of similar. I saw the Filecoin proposal. We also had a new multi-hash with the size of the deal. So like I like multi-hash abstraction, but it turns out like it's not that doesn't solve all the problems at the same time. And it would be good if BitSwap could work with the more with other cryptographic primitives, not just hashes, for data verification, like ZK proofs, for example.
Yeah, thanks a lot for that talk. On a conceptual level, it was great. I have a ton more questions about the mechanisms involved here, but I'm not going to go into those right now. I wanted you, if it's possible, you mentioned there's a number of open problems that would dramatically, if solved, would dramatically improve the way that data dissemination is working, advertisement, discovery. Could you list out what those problems are currently for the community to like, potentially congregate around those and like try to solve? Because I'm sure that, there are mechanisms that you would like to see implemented in lib2p that we can all kind of like as a community work together towards as well. And this like maybe like feeds into kind of like, one of the sessions that is also planned for later today, which is like the joint road mapping, right?
Oh, that would be awesome. I'll definitely do this. And like me and Vlad, we will like already have a draft of various problems we have on our current P2P network and what we need to improve on. It's not finalized. And it's also like sometimes hard to, you need to like research more of the problem itself to define it better. Right now it's like very vague and it's not even clear like whether it's the right description of a problem or not, yeah, we will definitely should do it, and we have plans for that as well. Right now we just launched, things should settle down, and we will continue improving the network.